Here's a little update on the Z80 Computer project. If you've been watching the last video I posted, I made this memory card here. And I finally fixed all the broken wires. And I ohmed it all out and it all connects just fine. But I tried plugging it in yesterday, and I put a little program on there. And it doesn't seem to work all that great. So the first issue that cost me a couple hours was I've got, as you've seen in I think part 2, the design of this reset card, reset and clock card. I've got 2 clocks on here, which is I've got 2 clocks on here. This is actually reset circuitry. And this is just an NE555 that is supposed to generate a slow clock, a 1 Hz clock, and this is a 4 MHz main clock. And what I found out is if I basically plug this in and have the processor card in here, and then also use this pseudo RAM card here that just has all the data lines pulled down, and it's just also an expander. But I get erratic signals if I plug in a logic analyzer to the bus and I look at the address bus. The counting is erratic and there's all sorts of stuff going on there. It counts 1, 2, 5, then it counts 1 again. What I then tried is I tried switching it over to the faster clock, and it actually works fine then. It counts alright. So either this slower clock is causing some sort of glitch, or this is actually from one of the lines on the bus spewing some sort of garbage into the Z80 processor. Although I pulled up or down all the inputs that are not used, so I don't know. Also, I measured this previously, but looking at the reset line during startup, I have some doubts about how well this automatic reset actually works. Because if you look at it with an oscilloscope, I think we did last time, but I don't know. I got some sort of spiky signals on there. And also what this thing definitely needs is an on-off switch. And then also a wired out reset switch, which it doesn't have at the moment. It makes it very tedious because I basically have to plug it in every time. So, okay. It seems to work fine with the pseudo-ROM and the faster clock. It does also seem to work alright enough if I just put a bunch of no-ops in here and then run it on the faster clock. Then, as far as I can tell, it works alright. Also, if you noticed, I changed to an EEPROM here because I blew out the previous EEPROM that I had in there, and also I fiddled with this yesterday for a while, and it's just so much more comfortable. In the final version, I'll switch back to a period correct EEPROM, but this is for testing and debugging. So as this is just an update, I won't show you any of the erroneous waveforms. We can look at this more closely in the next video, which is about the memory card. Although I think this will have to be pretty. If things look like they look at the moment, this will have to be a pretty extensive redesign. I think I'll probably redesign this card to some extent, and then try to get this working. Another possibility that I didn't actually talk about is this processor card is completely unbuffered. So this is just basically just connecting the processor out. What I did previously was to design a buffered card like this, and this doesn't work. It's a giant mess. But maybe the problem here is really with this fairly large backplane and the processor driving this. I don't know. So I'll probably have to think about that and do some designing and some testing. I actually thought I would have the memory card, gotten the memory card done by now, but as it turns out, building computers is hard. It's actually quite difficult. And then, again, problem with the Z80 here is... Z80 is over there, actually. Problem with the Z80 is it's a fairly complex... For the vintage, it's a fairly complex processor. It can do a lot of things. It is fairly powerful. And I think doing this on something like a 6502 is probably a little easier. Albeit that also has its idiosyncrasies and whatnot. But Z80 is a fairly complex processor to begin with. So, yeah, I'll keep you posted, but the memory card video, it will be a while. And yeah, I think also I thought about the read-write decoding stuff yesterday, and I think this actually works pretty well. So maybe I'll get a schematic out anyway. So let's look at the schematic here. We've got our ROM here. I'll just switch to a pointer that doesn't have a brand name on it. So if you look at this here, we've got our ROM here, the RAM here, and the address lines and the data lines are just common together. So just forget about these for the moment. And then we've got these two OR gates here, which is read. So read or memory request will enable the outputs of these. That makes perfect sense. And then write or memory request will enable the write enable on this chip here. So on the RAM, because if we want to write to the memory, we need to have the write enabled on the RAM, but not the output. And this is just what does that. And then to switch between the memory, here is basically we want the upper part is the RAM. So from the upper, so A13 to A15, these are the upper 56K of the address space. It is actually a 128K RAM, so A16 is just grounded out. Whenever these are high, this is basically a free input OR gate here that we're making ourselves within the same chip. We want this chip select here, which is active high. We want this to be high, which this will provide. And then also we go over here, and this chip enable here is active low. So if we get this high, then we'll basically switch off this 8K and switch on this 56K. So I think the problem is not with the decoding here or the address lines or whatever. I think the issue is somewhere else. Either there's still a broken line that I didn't find, although I tested it all with a multimeter and I think I fixed all the breaks. And also if I plug in my logic analyzer here into this chip socket, I get the right addresses. Same down here. But something doesn't work well. Also, I think I need to read up on how the dynamic memory refresh stuff works, because whenever the refresh line on the Z80 goes high, I get a bunch of stuff on the data bus that that makes sense if it's refreshing the dynamic memory, but I don't know what this does to my system. So yeah, that's where we are with the Z80 project. So I think I'll definitely carry on with this. Definitely. But I think I have to redesign this card. And maybe I'll build myself a smaller system first on a breadboard or something, where I can actually test these sort of things before I make the card. Because making these cards by hand is it's a lot of work. And it makes prototyping relatively slow, so maybe I should test it on a breadboard first. I mean, there's numerous systems out there that have demonstrated that you can actually have a fairly nice system running, even CPM on a breadboard. So that should work. Yeah, I think I'll fiddle around with this a little bit more and then maybe build myself a demo system to help with development, because I don't really know what's happening. But we'll look further into this once I get the video about the memory card out. Yeah. But I don't want to post the real video about the memory card before the memory card is actually working. So this will be a while still.